Welcome back, pre-calculus. In this video, we're going to talk about some more logarithmic properties, and we're going to apply them to the types of problems that we're going to be doing. So what I'm going to do for this video is I'm just going to start off by giving you these three properties, and then I'm going to work through a bunch of examples. I think that's kind of the best way here. So here is what we would call the product rule of of logarithms. Here's our product rule. We have log base b. If I take the product within our logarithm like this, I can actually separate this out into the logarithm base b of m added to the logarithm base b, let's make that neater, base b of n. We also have what's called the quotient rule. Which says that if I take the log base b of a quotient, m divided by n, that's equal to log base b of m subtract log base b of n. And we also have the power rule, which tells us if I take log base b of m, and that's raised to the nth power, that's equal to n. I can actually bring that exponent down in front like this and say that's equal to n times log base b of m. And I realize I forgot something here with our product rule, which is that our base has to be greater than 0 for this product rule to work. This only applies when the base is greater than 0. And I want to point something out to you about all of these different rules, which is that the base stays the same. The base has to stay the same. So these rules are for expanding. We can take something with a product in the inside of the logarithm and break it into two pieces like that. We can also go the other way, and we can take these two logarithms and combine them into a single logarithm here. But we can only do that when we have the same base. So I'm going to go through some examples, and I'm going to go through examples of both kinds where you expand one logarithm into many and where you condense many logarithms into one. So I'm going to start with this example. And here's how you'll see these instructions here. This example is from your interactive textbook. So if you'd like to follow along with their steps and methods, you can. You can also just watch and see what I'm doing. So here we have log of x squared y cubed divided by the log of z to the fourth. Wow, that's a lot, right? But actually, these three rules are all we're going to need here. All we're going to need. We're going to use the product, the quotient, and the power rule. So here's what we can do. I'm going to start off by doing the quotient rule. I see here that I have the quotient of two things. I have my numerator here, x squared y cubed, and my denominator here of z to the fourth. So this logarithm, I'm going to rewrite this using my quotient rule. Log of x squared y cubed minus log of z to the fourth. And this is using my quotient rule. And now I see that I have some things still here. So I have here, I have some products and I have some exponents. Here I just have some exponents. So I'm going to use my product rule next. And I'm going to take this logarithm and separate it into two using my product rule. Log of x squared plus log of y cubed. And then I still have subtract log of z to the 4th. And that's using my product rule on this logarithm here to separate it into these two logarithms. Now, in each of my remaining logarithms, I have an exponent. So I'm going to use my exponent rule in each place. That exponent rule says take this exponent and bring it down to be a coefficient. So we will end up with 2 times the log of x plus 3 times the log of y, subtract 4 times the log of z. So that's what it means to expand this logarithm. And I know that I'm finished with this. I know that I'm completely done because there's nothing else I can do to simplify this statement inside parentheses for each of these logarithms. By the way, you would call this in here the argument of the logarithm. You can call this the argument. So the argument here is in fully simplified terms. That's one example. Let's try another one. This one relies on you to remember some previous information about square roots and exponents. So what if I told you to expand the log of the square root of x? You might say, Sarah, I don't see products, I don't see quotients, I don't see exponents. There's a hidden exponent here. I can actually rewrite square root of x in this way. I can write this as the log of x to the 1/2 power. Now I have an exponent, and I can use my exponent rule to bring it down in the front as a coefficient. And so this would be 1/2 times the log of x. All right, hopefully you might have seen that before in another algebra class. This is something to do with exponents, though. If you want to review that, there's a section in your textbook on algebra basics that covers that information that can help remind you. We're going to do another example like that. What if I expand? I tell you, you know what? That wasn't easy. That wasn't hard enough. Now I want you to expand ln of the cube root of x squared. And you would say, oh, Lord, Sarah, why are you going to do this to me? You just did that with square roots. I'm so confused. And what's this ln? Don't worry. We'll decipher all of this piece by piece. So first of all, ln is a log with base e. So it follows all the same rules as our logarithms. So we'll be able to use all of our properties that we've been working with. The second thing is that we will actually be able to rewrite this expression in here as an exponent. So I told you that the square root can be written as raising something to the 1/2 power. The cube root, I can write this as saying ln of x squared to the cube to the 1/3. And this 1/3 here is taking the place of that cube root. Now there's two different ways you could solve this from this point. You could, if you remember your laws for combining exponents, you could recognize that I need to multiply these two together. And that I have the ln of x to the 2/3 when I do that. And then say, here's my exponent, and let me apply my exponent law and bring it down to the front. Now I have 2/3 ln of x. That works, but what if you forgot your rules of exponents? What if you forgot? That's okay. You can just apply the rule for exponents twice here. You could have said, I don't remember what to do when I multiply, when I have an exponent raised to an exponent. That's okay. Our log property of exponent says this exponent becomes a coefficient, and this exponent becomes a coefficient. And then you would multiply them both together out here, and then you get 2/3. That would be your final answer there. And I know, again, that this is my final answer because my argument for my log is just one single variable. All right, let's do a really hairy one. Are you guys ready for a really hairy one? I'll go step by step, and I'll label each time what I'm doing. So here's our instructions are to expand. And here's our statement. Log base 6 of 64x cubed times 4x plus 1 divided by 2z minus 1. We can do this. Don't fear. So I like to take a second and look at these and think about, this is really just a combination of our three rules. I see some products in here. I'm multiplying together these numbers here and here. Those are products. I see the division bar is telling me that there's a quotient. I see that I have some exponents in here. Not a problem. We'll be able to make this work. So the first thing that I'm going to do is I'm going to apply my quotient law. So we're going to do quotient law. And I promised I would label each step, so here we go. Quotient law. And that's going to allow me to take my numerator and subtract my denominator like this. So I'll end up with log base 6 of 64x cubed times 4x plus 1 minus log base 6 of 2z minus 1. All right. And now I'm going to use my product law, because I see here that I have a product. I have 64x cubed times 4x plus 1. So I'm going to use my product law. And that's going to leave me with log base 6 of 64x cubed plus log base 6 of 4x plus 1 minus log base 6 of 2z minus 1. And there's still more I can do. And I see here that I actually have a product here, 64 times x cubed. So this becomes, I'm going to tell you, I'm using my product law again. And you might be asking yourself, Sarah, could I have done both of those product laws at the same time if I saw them? Yes, you can. But I'm teaching, so I'm going step by step. As you get faster with these, you'll apply these laws just lickety-split. So now I have log base 6 of 64 plus log base 6 of x cubed. Sorry, my x cubed is getting a little wild there. Let's put my 3 up there. And then I'm going to add to that log base 6 of 4x plus 1 minus log base 6 of 2z minus 1. They're not kidding when they say expand your statement, are they? So let's see what else we have here. And there's one obvious exponent and one tricky exponent. I say obvious, but really nothing's that obvious in math. I'll just show you. I see I have an exponent here, this x cubed. I have a hidden exponent here with 64. I have a hidden exponent with 64. See if you can figure it out. I'll give you a second. You can pause the video and come back when you think you know what that hidden exponent is there. Some of you probably guessed 1. You're not wrong, but I want to call your attention to, let's go ahead and highlight this 64 in green. And then I'll do a little bit of scratch work down here in green also, so you can see what I'm thinking of. I know 64 is actually equal to 8 squared. But if you watched my other videos, you know that I told you that powers of 2 are really important. This is actually equal to 2 to the 6th power. 2 to the 6th power. And this is one of the reasons I told you powers of 2 are worth kind of knowing at this stage in mathematics. So we use them a lot for examples like this. So we actually we rewrite using our law of exponents here. So I'm going to, first I'm just going to do a substitution of in of 2 to the 6th for 64. So we end up with log base 6 of 2 to the 6th power plus log base 6 of x cubed plus log base 6 of 4x plus 1 minus log base 6 of 2z minus 1. So now we have two exponents, and I'm going to apply the exponent rule here, which says that this 6 becomes a coefficient, and this 3 becomes a coefficient. And we'll use our exponent law. And we'll have here 6 times log base 6 of 2 Oh, you guys, I see something better. We can do better than that. We can do better than that exponent law. In our first video, we learned a property that says if I take, oh no, we didn't. Dang it. I'm sorry, guys. 6 times log base 6. You know, I'll tell you how I got confused of 2. As I was looking at my log base 6 here, and this 6 and this 6 got me all excited. I thought there would be some cancellation I could do. But really, for there to be any cancellation of the log using properties from our first video, the base would have to match the argument. And I see here that the base and the argument do not match, so there's no cancellation I can do of the logarithm. But I got excited seeing that factor of 6. I don't know if any of you were trying to do that cancellation as well, but the reason we can't do it is that the 6 and the 2 don't match. That's okay. 6 log 6 of 2 is pretty good. That's a pretty good expansion. And then here, using our exponent law on the next term, we'll get 3 times the log base 6 of x plus log base 6 of 4x plus 1 minus log base 6 of 2z minus 1. I know my 2's and my z's look kind of the same. That's why I do that little slash through the z, so that you know that's a z instead of a 2. It's my little notation for myself. I claim this is our final answer, but let's go through each term and just make sure that there's nothing else that we could expand here. So in my first 2 terms, I just have a single argument, so that makes me feel fairly confident there that there's nothing else I could simplify. But a common question students ask is, can I simplify this at all? Can I do anything with this? And your answer is no, you can't. You can't do anything here. Even though this argument is more complicated than what I highlighted in yellow, remember the laws we have are exponent law, we have product law, and we have quotient law. But what do we have here? We have a sum, and here we have a difference. We don't have sum and difference laws. So we don't have a way that we can actually approach to break this argument down any further than what we've got. Okay? So this would be our final answer. That was a hairy one. I hope you guys enjoyed that example. So those are some examples of how you can use these rules to break logarithms down into many different pieces. Sorry, my iPad's biting me. I am going to give you some examples as well of condensing logarithms. So here are some examples. We could use these rules in reverse. So what if I said, instead of expand, what if I tell you to write something as a single logarithm? And that's what we're going to do with these. Write as a single logarithm. So suppose I take this statement here, where we have log base 3 of 5 plus log base 3 of 8 minus log base 3 of 2. So what you're looking for here is addition and subtraction, because that will be related to the product rule. So I see that we have both addition and subtraction. And it doesn't really matter which way you start, you should get the same answer. So let me show you how I start. I look at my addition first, and I say, that's my product rule. That's the product rule. So I'm going to use that to condense those logarithms into one. So I'm going to end up with log base 3 of 5 times 8. And then I'm going to subtract from that log base 3 of 2. And then now I'm going to go ahead and see that I have subtraction. I have these two logarithms are being subtracted. So that's going to tell me that I want to use my quotient rule here. And so I'll end up with log base 3. And in the numerator, I'll have 5 times 8 from the first logarithm. And in the denominator, I'll have 2 from the second logarithm. And now I'm actually free to go ahead and simplify this argument as a fraction inside the argument. So I have log base 3, and 8 and 2 have a common factor of 4. So I have 5 times, or they have a common factor of 2, excuse me, 5 times 4. So this is actually saying log base 3 of 20. Which now you could go ahead and enter this into your calculator if you like. You might want to use your change of base formula. Which would say ln of 20 divided by ln of 3. And then you could find a final answer. Let me type that into Desmos. So you could say ln of 20, and then you would divide that by the ln of 3. Sorry guys, Desmos is fighting me. ln of 3. And then you would get approximately 2.7 would be your final answer there. And you can see it's a little bit easier to do one change of base formula at the end than it would have been to go through and do all those different change of bases in each one. So that's one way that you can condense logarithms. Let's do that again. Let's do that working with some variables. So here again, we're going to take a larger expression. So we're going to start with 2 log x minus 4 log x plus 5 plus 1 over x times log 3x plus 5. Don't be afraid. We can make this happen for you guys, okay? So here's what we're going to do. We're going to look through, and remember, we're looking for product rules, quotient rules, and exponent rules. So the first thing I like to do is I see that I have these coefficients hanging out in front of my logarithm. And I know that they got here, that they are related to exponents of the argument. So I'm going to use my exponent rule to move them into their rightful place as exponents here in the argument. And that's what I'm going to use first as my exponent rule. There's multiple ways to do each of these problems and still have the right answer. So if you like to do other stuff first, you can try it out and see if you get the same answer as me. So here we end up with log of x squared minus the log. Here's where you have to use caution. Because this entire argument is what's getting the exponent. Not just the x, not just the 5, but the entire argument. So you're going to end up with, in here, x plus 5 to the 4th power, like that. And I know that some of you probably looked at this 1 over x and you got really intimidated. Just follow the rule here. You don't have to worry about what it means to take something to the 1 over x power. to be able to combine these. You know that this coefficient becomes the exponent in here. So you end up with that to the 1 over x power. That x looked like a little spider. There we go. 1 over x power. And even though you don't know what it means, you know you followed the rule. You should know what it means, though, you guys. Ask me about it in class if you don't know. I want to hear from you. And let's see. So we did our exponents, but there's still more condensing I can do here, because I see that I have some subtraction and I have some addition. Typically, students here get a little bit nervous because they're not sure what to do first. Like, do I do the quotient rule first or the product rule first? It really doesn't matter. You'll get the right answer either way. So let me here do the product rule first. I'm going to say I have this logarithm and I'm adding that logarithm, and they have the same base. So I'm going to use my product rule, and I'll have log of x squared minus, notice this minus sign I'm keeping, the log of x plus 5 to the 4th power times 3x plus 5 to the 1 over x power. And now I'll use my quotient rule. And I'm going to say this will be my numerator here, and this will be my denominator. And so that'll give me the log of x squared divided by this mess down here, x plus 5 to the 4th times 3x plus 5 to the 1 over x. And now I've written this as a single logarithm, and that's how you know you're done with these condensing problems. Once you have one logarithm at the end of the day, you are completely done. Isn't that nice? Let's do another nice one involving some numbers here. You guys could hear that truck beeping its horn out of my house. Rude. Log base 3 of 24 plus log base 3 of 2 minus log base 3 of 6. So I'm going to here show you what happens if I do my quotient rule first, because I think I've been doing the product rule first a lot, and I want you guys to see. What if I do my quotient rule first, and I look at this here, log base 3 of 2, subtract log base 3 of 6, and I combine that using my quotient rule. That'll give me log base 3 of 24 plus log base 3 of 2 divided by 6. And I can reduce that fraction to be in lower terms, so I'm going to do that in my next step. Now I have log base 3 of 24 plus log base 3 of 1/3. And now I'll use my product rule to combine these two. That'll give me log base 3, and then I'll take the product of these two, 24 times 1/3. And that's going to work out to be log base 3 of 24 divided by 3, which will be 8. So then we have log base 3 of 8. I'm going to go ahead and use my change of base formula to say ln of 8 divided by ln of 3. And I'm going to type that into Desmos a little bit faster than the last time. Ln of 8 divided by ln of 3. I get approximately 1.89 as my answer. So that's how you use these rules of expanding and contracting your logarithms. There's a bunch of exercises about how to do this because you really need to practice. These take a while to fully master, and they're really important next week when we start trying to actually solve equations that involve logarithms. So please practice these. I know it's tough because there's a lot of new rules to learn and try to understand, but the more you practice, the more you're going to learn. I want your focus when you do the homework. I want you to focus on what mistakes you make. On what mistakes you make. And I really want you to bring them to class. This is one of the topics that I'm most excited about to cover the way that we organize our class, because you guys are going to find some really cool, interesting mistakes that are going to show us really what it means to be able to work with these properties. And by the time we solve equations, I think you will have already gone through most of the mistakes that typically come up, and you'll have learned from them, and you'll be tough and ready for equations. I look forward to hearing from you guys and what you've learned. I hope you're safe and you're well.